Now we're getting into some of the sweet spots for me within the CCIE Enterprise exam. Software-defined networking and automation now combine for 40% of your score on the CCIE lab exam. So it's important to know these things like SD-WAN, deployment and design, SD-Access, deployment and design, and network automation. So in this video, we're going to tackle one of those, SD-WAN, but they have said they're keeping it at a pretty basic level. You just need to know the basics of deploying SD-WAN for vEdges, templates, and policies, and that's what we cover here. Now, fair warning, I do run into a software issue at the very end of this video, basically when we're about to click done, and the whole thing blows up on me, and we never actually get to see the final piece come to life, but that's okay because the core section of the task we've definitely got covered, and the way that I implement the last thing that we're going to cover here, I know it actually works correctly. I just ran into a software issue and the whole system kind of got hung up on me. So bear with me on that one, but here we go. We're going to jump into SD-WAN. You're going to see Viptela in action and how we can push templates and policies down to our devices. Let's go. All right, it is now time to talk about SD-WAN, which is such an exciting technology. People are, really amped up about SD-WAN. They're really amped up about new exams centered around it. And we're really amped up to see it on the CCIE blueprint. I felt the same way about automation and SD-Access too. These are modern technologies, and these are things. The SD-WAN environment itself is, I don't want to say crowded, but there's good competition in there. And Viptela is a fantastic product that was, quite frankly, fun to learn, fun to lab, and fun to record on. So with that being said, it's not a simple product. It's definitely a professional level product, professional level exam in the ENSDWI, which we on Twitter affectionately call it the in sandwich. So if you're new to SD-WAN, this kind of goes hand in hand with what I'm saying in the SD-Access course. Like, there's an expectation coming into this task that you've seen some of this before, and you won't be learning things for the first time here. I hope you learn something, but my intention here is not to teach SD-WAN so much as, here's an exam environment, and here's how they're going to question you about it. The other thing about this is just the way EVE-NG and emulation works in general. There was no real clean way where I could transport configurations to you. vManage itself runs off of a hard disk, even if it's an emulated hard disk. So you can't even export the configs from it. So there's no startup config. The expectation here is that if you're going to be trying to follow along in a lab environment, that you have, of course, have your own images that you've acquired in the most legal way possible, as well as have stood up the controllers in your environment. Standing up the controllers are not part of the CCIE blueprint. So it's you don't have to know how to do the CCIE blueprint in that regard. That doesn't mean there's not things that are relevant that you would learn, like how the CA certificate configuration really works and why the organization name is so important. Also how zero-touch provisioning would work. Those all may be coming up as part of the exam environment. So in my environment here, I've already got vBond, vManage, and vSmart up and running. In fact, I'm just going to go over to vManage here and log in. So the way this is working is I'm coming in from the outside. I've got a static route like in my firewall somewhere that pushes the subnet into the NAT out router here, which then can route directly into the Ethernet 0 interface of vManage. So you can see I've already got vSmart, vBond, and vManage stood up, and they are up and running and communicating and healthy. We have no WAN edges. Again, showing that I've already got the control plane stood up here. If I go into devices, you can see I've imported a device list, the WAN edge list here. I have 10 vEdge clouds and 10 CSR 1000Vs. I'm not using a C-Edge in this particular instance, but I would probably say it would behoove you to learn how to stand up a C-Edge device. So to that note, I want to share this with you. I'll just bring this up on the screen here. These are the commands that I use to stand up a C-Edge device. Of course, the IP addresses are specific to me. But, screenshot this or pause the video and just take it in. This is how I brought up my C-Edge devices to life. And yeah, so if you get into an exam environment situation, Those are the commands that I think are relevant to you. Now, the next thing I'll say before we go any further, again, if SD-WAN is new to you, if standing up devices, standing up the control plane, getting this all working in EVE-NG is new to you, we actually have content dedicated to this on CBT Nuggets. Keith Barker actually shot a skill that was something along the lines called Build an SD-WAN Practice Lab. And it was all about how to stand this up in EVE-NG, including setting up the CA server, getting the certificates installed, how to bring C edges and V edges into inventory, and it is fantastic. Then, of course, beyond that, Jeff Kish, Keith, and I go super deep into how to actually implement an SD-WAN topology and environment. So the lab tasks here that we're about to cover will actually be a breeze for you if you've covered the SD-WAN content in CBT Nuggets. So let's do it. Lab tasks, SD-WAN. All right, customer one is trying out SD-WAN as a solution in 2 new branch offices that are opening up across the country. They are using an on-premise hosted solution, and the controllers have been deployed by a consultant. The vManaged controller can be accessed by that IP address on the normal port it listens on. So immediately, what port does vManage listen on by default? 8443. A lot of browsers you can type in 443 and it works just fine. But the first time you access vManage, you may have to type :8443. So just keep that in mind that 443, while it usually works, 8443 is very often the norm. The vEdge devices need to be bootstrapped and brought into inventory. Organization name should be whatever works in your lab. In my case, that's Knox's data. Site ID for vEdge 10. I see they're labeled right there, vEdge 10 and vEdge 20. Is 10. Site ID for vEdge 20 is 20. Set the system IP to be something that will easily identify the vEdge device. So my system IP naming scheme has been 777, then 10, 20, and so on. So I'll probably stick to that. vBond is reachable via the public internet at 10.10.106. Configure an IP address on each WAN link, as well as configure the gateway IP address to be the ISP routers, as well as configure the gateway IP address on the ISP routers. Confirm that new prefixes are sent through BGP. So if I look at this, I see that GE00 on both of my vEdge devices connect in. One goes into ISP 400-3, one goes into ISP 100. So I'm going to configure an IP address on vEdge 10 and vEdge 20, but then I got to also make sure that IP address is on, or the gateway IP address will be on the ISP, and then those prefixes need to be advertised throughout the BGP environment and the internet. Install the CA certificate on the device. So again, this kind of goes back to where I've already set up the controller, and I have the CA certificate sitting right here on my desktop. So you can actually do open with, notepad, there it is. We'll get to that when that time comes. And perform the vEdge onboarding operation to bring the vEdge into the controller's inventory. All right, let's just get started. I'll bring up vEdge 10 as well as vEdge 20, and I believe this is the first time I've turned these on. So it's gonna, oh man, that's bad news. I've already typed the password wrong. Let it blow up on me. All right, admin. Password is admin. I'm just gonna keep it on admin for simplicity's sake. We'll go into config, system. There we go. Host name is going to be, in this case, vEdge 10. Site ID, we said was going to be 10. System IP, I said was going to be 777, in my case, 10. Org name is Knox's data. Do I need anything else here? vBond, of course. What am I thinking? vBond 10.10.1.106. Okay. Anything else I'm trying to think about here? Don't know that I need anything else to make this come to life, right? I don't think I need anything else here to make this come to life. So now we got to go into VPN 0, which is the WAN VRF effectively, and interface gig E00. Is that the interface that these were on, I said? Let's make sure. Yep, interface gig E00. IP address. Oh, what do we want to call this? Just to make sure, let's bring up the ISP 403. Make sure there is no IP address here. Interface brief. And this was going to be on, I think, 10. Yeah, this is on 10. So there's no IP address on either side. So the world is our oyster here. Let's go with like 172.28. Let's call this for site 10. And I'll say 10/24. So 172.28 will be my WAN side. Actually, I'm rethinking this now. And how this, I think we'll be okay. 172.28.10 will be my WAN side, and that's fine. Tunnel interface, we'll say this will be the tunnel interface. Exit and exit. Let's set our IP route 000/0 towards 172.28.10. Let's say 1. And now let's go over to ISP 400-3. Interface ETH1/0. IP address 172.28.10.1 255.255.255.0. No shut end. Okay. So this comes to life. Now I should be able to commit and quit. And I should be able to ping 172.28.10.1. Looking good. Can I ping the VBON device itself? Probably not, because this is not advertised in BGP yet. So let's go into do show run. I forgot what. I know this was in a confederation. 65,006. Router BGP 65,000. Nope. 6. Address family IPv4 unicast and network 172.28.10.0. Mask 255.255.255.0. So this should be propagating throughout BGP at this point. And just to verify, I'll check out like ISP 100. Show IP route 172.28.10.0. Can it take CIDR notation? I never remember if it can take CIDR notation. Okay, so there we go. We see it advertised. This actually came in from the AS300 is where we learned it from. Show BGP IPv4 unicast. Let's just do them all. 172.28, there it is. Came in from actually both those. So ISP 300 and 200 advertised it in. We're looking healthy and good there. So now from vEdge 10, can I do 1.106? There we go. We got return traffic coming from the vBond appliance itself. Let's stand up vEdge 20 now. Admin, keep the password the same. Config system, hostname, vEdge-20. Site ID 20, system IP 777.20. Organization name, Knox's data, and vBond 10.10.1.106. Go into VPN 0, interface gig E00, IP address, let's say 172.28.20.20/24. And this will be tunnel interface. Exit out of interface config mode. IP route 00000 172.28.20.1. Back to ISP 100. Show run. Nope, show IP interface brief. Looking like it's going to be on 1.1. Let's just confirm that real quick. Right. Nope, this is on 1.2. Interesting. Okay. Glad I checked. Config T, interface Ethernet 1.2. IP add 172.28.20.1 255.255.255.0. No shut. Exit router BGP 100. Address family IPv4 unicast. Network 172.28.20.0. Mask 255.255.255.0. End. Okay, let's verify this real quick. Commit and quit. Ping 172.28.21. Return traffic. Can I ping vBond 10.10.1.106? Return traffic. Okay, so we can now communicate to vBond. Let's check a look at our steps one more time. So all of these are done. Advertise through BGP. Install the CA certificate. That's what's next. Okay, so to install the CA certificate, you could obviously SCP it from the CA server, since we can reach the CA server. We can also install it manually, which is exactly what I plan on doing. So I believe it's vshell to take me into vshell. And I can do ls. There's nothing here. I can print working directory. I see I'm in home admin. So what I'm going to do is I'm going to say vi. We're going to create a file called ca.cert. I'm going to press I for insert. And I'm going to grab the entire CA certificate here and paste. Now I'm going to press escape, :WQ, enter. So there we go. The certificate, now if we do ls, the certificate is listed there. I can exit out of vshell, and I can say request root cert chain install home admin ca.crt. So the same CA certificate that's installed on vManage that's going to be used for issuing certificate chains and everything like that is now trusted by vEdge 20. Let's make sure we do the same thing over here on vEdge 10. vi ca.crt. I paste escape :WQ enter. Now exit, request root cert chain install home admin ca.crt. Okay, so now the thing is when I go into that shell, like now my console's kind of jacked up, so I'm actually just going to close everything and reopen it real quick. So now vEdge 10 and bring up vEdge 20. Cool. Okay, so last thing, perform the vEdge onboarding operation to bring the vEdge into the controller's inventory. So here I need to grab the chassis number and the token. So I'll just grab the first vEdge cloud in the list, generate bootstrap config, cloud init, click OK. I'm going to grab the first UUID, that's the chassis number, say copy. And from vEdge 10, we'll say request, was it vEdge cloud activate chassis number? Okay, there's the chassis number. Token. And let's grab the token, which is the OTP. That's one-time password, also known as token. And paste. So we'll press enter here. Give that a couple minutes to find its feet. We'll repeat the steps over here on the next one, the next vEdge cloud. Click cloud init. And I see vEdge 10 just came on board in the background. Okay, so there we go. So we'll grab the same chassis or different chassis ID for vEdge 20. Request vEdge cloud activate chassis number, paste, and token. Let's grab the one-time password here and paste it in. Okay, so switching back to vEdge 10, I can now do show control connections. None. I was expecting to see some control connections that might be coming to life. Let's do show control. Oh, it's because we haven't provisioned any templates yet. But if I do show control local properties, let's see, my token is now invalid, which means this device is now coming up. I can actually see the state is in the up state here. So we're getting there. It's going to be okay. In a little bit, we'll actually have the control connections in place once we've started pushing templates down to this device. But now I can jump back to the vManage portal real quick. I see both vEdge 10 and vEdge 20 brought in here. If I jump back to my main dashboard, I now see the two WAN edge devices are showing, interestingly, in a down state. They should not be unreachable. Let's refresh. Okay, okay, now they're coming online. So there we go. It takes some time. They got to get to know each other. This is the first time these WAN edge devices are communicating to vManage and vSmart. So there's a little bit of work that goes into it. So let's just give it a little bit of time. You can refresh this page too, especially in the virtualized environment. This thing is a little finicky. So when you refresh the page, it does kind of reset the data, so to speak. So we'll just kind of let it find itself. After a couple minutes, we'll come back to it and make sure these devices are all online. I can actually go to the devices too. This device is now in sync. We can now see the site ID. So it's still just syncing information between the vEdge 20 and the other nodes. And that's just what it's going to do. There we go. Now they're both online. And if we go back to the devices, they'll both show as in sync. There we go. And in a moment, the site ID will pop up here too. I'm not worried about it right now, though. So everything's fine. Okay, let's take a look at our next tasks with regards to this. So now, step 1, the vEdge devices need Bootstrap is done. 2, configure IP reachability from the provider edges in the MPLS network to 10.10.1. It's okay. So now we're focusing on the MPLS network here, and these devices will need to be able to get via R1 up to the border router and then to the VBON device as well. So I need to bring up R4, R1, and R5. I'm going to do this in numerical order though, so I'll start with R1, then I'll do R4, and then I'll do R5. So let's take a look at this. Let's start with R1. Does R1 have a route currently to 10.10.1? Show 10.10.1 0 255 255 255.0. Network not in table. Show IP route just for a cleaner way to see it. So it's not there. It doesn't even know how to get there. So the first thing we need to do is we need to have static routing in place that says to get to 10.10.1, it needs to go out R1. So before we do that, we need to actually configure IP addresses in place between R1 and the border router. So this is E10, the interface brief, do show IP interface brief. E10 does not have, it does have an IP address, 172.29.31.1. Do ping. Okay, so there's an IP address on the other side too. So I can actually do IP route 10.10.1 0 255 255 255.0 destined for 172.29.31.2. Completely forgot that I gave those IP addresses there. Okay, and now if I do ping, cool. So we can now reach the VBON device, but R4 and R5 need to get there too. So let's do show IP route. I could do something like redistribute static because we're running OSPF. That would be fine. In fact, because we're running OSPF, I actually really like that idea. Okay, let's do that. Router, OSPF. That OSPF v3 threw me off there for a second. One network, 172.29.31.0.123.255. Area 0, no, area 123450, right? That's what we did. And now I'll also say redistribute static. I don't think I need to do anything else here, really. I mean, I could set a metric, or let's do subnets. Let's actually do a metric of like 10, and let's say metric, just keep it clean, metric type 1, something like that. So now, if I look from R4's perspective, show IP route, might still be waiting on some LSAs to come in. Okay, there it is. So now I should be able to ping 10. Nope, the return traffic's going to need to come through this way too, isn't it? Let's take a look at border router and make sure that it knows how to get to the 172.29s. Show IP route. It knows how to get to 172.29s because it has a static route for a /16. So that's good news. So let's do ping 10.10.1 106 sourced from my address where I have 172.20, which is Ethernet 03. The issue is that R1 does not know how to return traffic to this interface. So let's do router OSPF 1, network 172.29, 10.0, 123.255, area 123.450. And we can do the same thing over here on router 5. Let's do show IP interface brief, config T, router OSPF 1. Actually, Is that right? This is on interface E03. Show IP interface brief. Yeah, that's right. Little brain fart there for a moment. Let's make sure E03 is over here. Yeah. Okay. Network 172.29.20.123.255 area 123.4.5.0. Okay. So now if I try and ping, we got round trip traffic. Can I do the same thing over here and ping 10.10.1.106 source Ethernet 03 round trip traffic. All right, cool. So now the MPLS network is set up and prepared for vEdge 10 for when vEdge 10 is ready to communicate back to vBond. Let's figure some new stuff out. Okay, step 3, properly create and assign templates to vEdges so that they create TLOC and OMP adjacencies on at least 2 colors. All right, so this is kind of a big task starting from scratch, but here we go. Let's start by doing feature templates. This is Keith Barker's teaching method where you build the small pieces first and then add it to the device template later. So I'll say, we'll call this VPN 0 template. How about that? Something simple. This is going to be VPN 0. Don't need name. Don't need any of that. Primary DNS address. Don't need that. I like turning static and connected on for OMP. Let's do IPv4 route. We're going to do a default gateway. Add a next hop. Our first default gateway is going to be device specific. But let's change the name there. Def gateway. Let's call it internet. So this will be our default gateway towards the internet. And let's add a next hop. We'll make this device specific. Def gateway. This will be towards MPLS. Add and add. Don't need IPv6, not doing any services, not doing any GREs, not doing any special NATs. Okay, so that should be, missing fields, description. Template for VPN 0. Okay, cool. Save. Oh, yeah, of course, OMP is not configurable for VPN 0. Duh. Right, knew that. Let's do the VPN 512 template as well. VPN. .512 template. VPN 512 template. Don't need to do really anything here. I'm just going to set this to be the ETH00 interface. In case we ever do need a management VPN, I'm just going to put it on there. Not doing any OMP advertisements, not doing any static routes for this. Let's just hit save. Always gets me. Just copy and paste, I don't care. Okay, now let's do our interfaces. vEdge Cloud, interface Ethernet. Let's call this interface gig E00. I'll put in the label here for internet to remind myself about that. Of course, we'll do this. Shutdown is going to be, nope. Interface name is going to be gig E0/0. I'll give it a static IP, but I will make sure to set this to be gig E00 IP address, and it'll be device specific. Tunnel interface will be on. Color for gig E00 is biz internet. I don't care about restrict. I don't think I need to do anything else here. Services here I'm okay with. We're not doing any BGP peerings on VPN 0. It might, nope, don't need I don't think we need netconf to be turned on. Not doing any outbound NAT at this time. Not doing any VRP. Not doing any QoS. Thank God. Not overriding MTU or TCP MSS. Not doing a tracker which is important for application-aware routing. All right, I'm just going to hit save. I think we're good for interface gig 00. Let's do a template for interface Ethernet 0, which is going to be our 512 template. So I'll say ETH00 VPN 512 is what I'll call it. No shut. Interface name ETH. Is it ETH0 or ETH00? Let's make sure before I say the wrong thing here. Show interface description. ETH0. It's not ETH00. Okay. And quite frankly, like I don't really care about any of this, so we can just click save. Here we go. In fact, we can even just shut this interface down. There we go. And lastly, we're going to set up the MPLS color because it did specify a second color for this to come up on. So let's do this. Let's do GE01 MPLS. No shut. GE 0/1. We're going to put this under MPLS IP address for device specific. Tunnel interface is on. Color is MPLS. Making sure everything else looks good here. I think so. Ah, the description every time, man. Every single time. Okay. All right, so we've got templates here. Let's now jump over here and create our device template. It's going to be created from feature templates. This is a vEdge cloud device. Template name is going to be vEdge device template. Something stupid like that. Okay. Don't need to change any of these things. Let's go to VPN 0 template, VPN interface. We got interface gig E001. Let's add another VPN interface for interface gig 00 and 01. VPN 512. Let's just grab it here, add a VPN interface for ETH0. Didn't say anything about service VPN, so I'm not worried about that. Let's create and let's attach it. Whoop. Edge. Attach. Let's go here and view it this way. Edit device template. All right. Host name is good. Address default gateway for the internet. For vEdge 20 was 192.168. Wait, no, we said 172.29, right? Show interface description. That was 172.28. It's 172.29 for the MPLS. So 28.21, 172.29, 21. MPLS address 172.29.20.20, 172.28.20.20. I can't recall if this, I think this does require CIDR notation. Host name, I'm not changing it, so I'll leave it on vEdge 20. System IP 77720. Site ID 20. Update. Got the green check mark, so everything's looking good there. Now let's do edit device template for vEdge 10, 172.28.10.1, 172.29.10.1, 172.29.10.10/24, 172.28.10.10/24, vEdge 10, 777.10, and 10. Update. Let's say next. We'll click on one just to view the config diffs, make sure everything's looking clean there. I'm going to take a sip of my Lebanese tea here for a second. Delicious. Okay. Looking good. Just out of curiosity, I'm just a little paranoid right now about, yeah, this is all going to work. It's all going to work fine. You can do config diff, which is pretty cool, and even side by side and see where it's changed. I really love that. Let's push it. Send it. Confirm change on 2 devices. Okay, YOLO. There they go. Back to the challenge. Okay, so this should bring up the T-locks, the OMP adjacencies, and there's 2 colors there. Create a service VPN that matches on both sides, like a service VPN 4. And including IP address configuration and apply. On both sides we have gig E02. So back to templates. Back to feature templates. Let's create a VPN template first. VPN. What do we say? VPN 4? I like 5. Round number better. Let's say like users VPN 5. That's fine. I don't really need to tinker with any of this stuff. I mean, you can put static and connected into OMP, even though that's, they're just going to do that anyways. Don't need to tinker with next hop routing or anything like that. OMP will handle all that business for me. Pretty straightforward. That creates VPN 5. We said we got to do gig E02. So VPN interface Ethernet. Let's say gig E02 VPN 5. Let's do no shut gig E0/2. Let's do gig E02. Oh no, what have I done? Gig E02 underscore VPN 5 IP address. Okay. Not a tunnel interface. Everything else looks good here for me. So let's check on our template deployment. Nope, right here. Yep, push template deployment was okay. If I check out like my VEdge 10 now, show run. So now I see OMP, I see both VPNs brought to life here. Show control connections. I got my control connections are up. Show IPsec inbound connections. I have one inbound connection up. Via Biz Internet. Cool. Just out of curiosity, can I ping 172.29.2020? So this is interesting. This should be coming up. Let's do ping. It's probably because it was coming from the wrong 29.20.20. Is it source? Enter gig E01. That traffic should definitely be traversing. Source from Ethernet 03. Where is it dying? So it makes it to router 5, no problem. It might be because we actually have ICMP turned off on the outside. Or it might be because I typed something wrong. Who knows? Show interface, description. Can I ping my next hop? 172.29.21. Source gig E01. Okay, so I can't even ping my next hop. That's because I set this to 5. Interface Ethernet 03. This should have been 172.29.21.255.255.255.0. And okay, better. Still interesting here. Yep. Still doing these a little wonky. 10, 1. I mean, that was my expected route, right? Show IP route. It's my default routes too. There we go. Now it's coming to life. So now if I do show inbound, show IPsec, inbound connections. Okay, there we go. Now we've got full mesh here. So the issue there was I set the IP addresses on R4 and R5 and then didn't configure the gateways correctly on the vEdge devices in the templates. So now that those are in place, let's jump back to my device template, edit it, and we'll add the service VPN. So let's add a service VPN. The VPN is users VPN 5. The VPN interface is gig E02, and update. Of course, this will want to push these templates immediately because these templates are already applied. What do we want to set this inside to be? 172.29.5. I'm okay with that. Let's say .20/24. Actually, no. Let's set this to be 25, and then on the other side of the tunnel, it'll be 15. So we'll say update for device 10, 172.29.15.10/24. Update, and next, and push it. Not even going to look. Okay, next challenge. Create a loopback interface on both vEdges that is in the service VPN you just created. I should have read ahead. Serves me right. Okay, back to templates. One more feature template. Let's see, vEdge Cloud, Ethernet, L0. No shut, loopback. Ooh. This is one of those things. Is it capital L or lowercase l? It matters on these devices. Shoot. Okay, so since it's like a 50-50 shot right now, I'm figuring it out. I think I'm going to go with lowercase l, set it to 0. But yeah, these things are case sensitive. They're very sensitive about what you type. So it does matter. Like lowercase l and uppercase L, those are two different interfaces. If you choose the wrong one, it's not going to work. So let's do this. We're going to do this and call this L0 IP address. It's going to be device specific yet again. No tunnel interface, nothing else here. Just setting an IP address on it. Let's jump back to our device template. This should have been pushed by now. Edit, and under VPN, the service VPN it said, we're going to add another VPN interface for loopback 0. Update. Edit the template. 20/20/20/20/32. Update and edit. 10/10/10/10/32. Update and send it. Okay, what do we want to do next? All right, that was step 5. We're on to step 6. vEdge 10 should form an adjacency with R14 in area 51.51.51.51 and advertise its loopback. So let's bring up R14. I don't think we have an IP address on it. We don't even have an initial config on it. And vEdge 10, one more time, show interface description. Well, there's my loopback address. We know that got there. 172.29.15 was the interface we were working with here. So R14, T, hostname R14, interface Ethernet 0. I'm pretty sure that's what it's going to be. IP address 172.29.15. That was 29, right? I got to check one more time. 29.15.14. 255.255.255.0. No shut. Interface, let's do loopback 0. IP address 14.14.14.14.255.255.255.255. Exit router OSPF 1. All zeros. Said area 51, 51, 51, 51. Now let's go back to vEdge 10 and start making that OSPF configuration. That's going to be a new template, feature. In fact, this time I'm going to do it the lazy way. I'm actually going to do it from the device template. And since this device template is applied to both places, it's just going to try and run OSPF on both devices, which is fine. We'll just make sure we configure it in a dynamic way. I'll choose create. Oh. So yeah, I clicked on it and then chose create template. Sorry about that, I went quick. OSPF, VPN 5. Router ID is going to be device specific. Don't need to change the distances, not doing redistribution. Am doing an area. 51, 51, 51, 51. I'm going to leave the... What do you mean invalid input? That's perfectly valid. Okay, so we may have run into our first little issue here with vEdge that I didn't know this was an issue. It doesn't take dotted notation for the OSPF neighborship. So let's just call it area 52. Jump back to R14 real quick. Give it a no network. And hit up a couple times. You just call it area 52. So sorry about that. That was our first learning lessons here. I thought that wouldn't have run into an issue. We need to add an interface. And our first interface is going to be gig E02. That's where the adjacency is going to come to life on. I don't want to change timers or authentication or MD5. There's no requirement for it, but this is where you could add it. And it also said we wanted to advertise our loopback in here as well. So I'm going to click add interface here. I'm going to choose, it was lowercase after all, so that's good news. Loopback 0 and add. And add. There we go. I'm not doing any OSPF throttling. Not doing default information originate. Autocost reference bandwidth, we can change that. Well, you know what? No, don't need to. So there. Now OSPF is going to get pushed to both devices. We do have a router ID configuration to set on both devices. So this is device 20. So I'm going to put 20, 20, 20, 20. Update. And for device 10, 10, 10, 10, 10. Update. Next. Configure. And send it. In a couple moments, I'll see the syslog pop up here. I can also do debug, IP, OSPF, adjacency, debug, IP, OSPF, hello, debug, IP, OSPF, packet. Take another sip. My voice is going out from saying all this stuff. There it goes. Comes neighbor adjacency right there. Isn't that fun? Isn't it fun? It's just loading to full, just like that. On debug all, show IP route. And there's the neighbor's loopback address that we learned right there. Similarly, on vEdge 10, I can do show IP route. And I see the loopback learned from OSPF right here as well. So much fun. All right, next challenge. Step 7, create a centralized policy that stops the advertisement of vEdge 10's loopback address to vEdge 20. And then the last one, create direct internet access for the service VPNs. Fun stuff. Okay, so we could do both of these at the same time. You do have to do them in the same policy. That is a thing. So we might as well do that. We've got to create our list first. Let's just start by adding a policy. Our VPNs that we're working with here are going to be in VPN 5. So I'm going to call this 5. I'm going to call it VPN 5. Right, because the loopback was in VPN 5, as well as configuring outbound NAT. Sites that are participating in here, we've got site 10. We're also got site 20. No spaces. We can, if we need to, create 10, 20. I'm not sure if we're going to need to. Might. Prefix, we want to match on 10's loopback. So I'm going to call this 10 loop. 10, 10, 10, 10 / 32. Not doing any... We are doing, if we're doing direct internet access, I think we are doing traffic rules. So this is going to be under data prefix. So our LAN to LAN was 172, what was it? On 172.29.15 and 172.29.20. So let's do 172.29.0.0/16. I'll call this service VPN 5. Give that a name. I don't think we need to do anything. Let's do colors just in case. BizNet, select color, BizInternet, add, MPLS. It's better just to have all the lists that you think you might need than to get into it and go, I forgot a list, and then have to go back. Okay, so I've made plenty of lists here. First things first, we are doing a topology change here. When we're doing the loopback, when we're stopping the advertisement of the loopback via OMP, this is going to be a custom control policy. So let's do a route. And when we say when it's originating from site 10, and prefix list is the 10 loop, reject that outbound. I wonder if I need to specify the VPN too. It might not hurt to specify the VPN. So this is going to be, the default action here is reject. So when it's originating from site 10, 10's loopback, VPN 5, reject it. Otherwise, accept it. Save and match. Let's call this reject 10 loop. Fancy description of stop advertisement of loopback 10. We'll specify what site that gets applied to, site 20, when it goes time to actually apply policies to sites and VPNs at the very end. So next we're going to do our direct internet access. This is going to be a traffic data policy. Sequence. Is this app? I don't think this is firewall. I think this is just custom. Okay, so when the source data prefix is service VPN 5 and the destination data prefix is service VPN 5, permit it. That's the first rule. Next rule is when the source data prefix is service VPN 5, the action is going to be permit, but then do a NAT VPN. And that default is NAT VPN 0. Shoot, we also have to enable NAT on the outbound biz internet interface. And I also want to tell it to do prefer the biz internet TLOC. Okay. What have I done? I hit the wrong button. No. Okay, so I'm going to pause. I'm going to recreate all this and get us back to where we were. 1 second. Actually, I think you can see, like, most of the stuff that we've already done was already created, so I didn't even need to pause. Like, all the lists are created. The topology that we just created is still here. It's import existing, so we can just choose the custom control and import the reject 10 loop. There you go. So now I've just got to recreate the traffic data policy here. I don't think, yeah, we didn't actually create it, so it's not here. So I'm just going to recreate this super quick. Let's call this the DIA policy, description, paste, custom, sequence, source data prefix, destination data prefix, boom, and boom, action, accept, don't change it, save, custom rule, source data prefix, not specifying a destination because it's anywhere else, actions, accept, NAT it out via a VPN, which is 0, prefer a local TLOC, which is biz internet, and save and match. Default action, you know, that last one we did kind of does match everything else, but I'm just going to put an accept anyways in case, you know, somebody does something with loopbacks or whatever. So save data policy. We got our data policy now. Let's apply this thing. We're going to call this mega policy. It's my policy to be mega. All right, so we've got the topology. So this is going to be outbound towards site 20, add. So this was going to be blocking that loopback outbound towards site 20 as it goes out of vSmart. The OMP advertisement goes out of vSmart towards site 20. The traffic data, we're going to select both sites here. Perfect, glad I made that. And the VPN is for VPN 5. And hit add. And I think we're ready to rock and roll. Let's push it. Activate. Oh no! vSmarts are not in vManage mode. That's right. A very important part to standing up all of this stuff is the vSmart has to be managed by vManage. So we got to create a new device template for the vSmart itself. So scroll all the way down. There's vSmart. Template name, vSmart. vSmart. Let's create a new VPN 0. Let's call it vSmart. VPN 0. VPN 0. Do I need to do anything here? Yeah, I need to set a default route. 000/0. Next hop. Add next hop. 10, 10, 1, 1. Add. Okay. VPN interface. Create a vSmart VPN interface. Which one? Where is this? vSmart ETH1 is in VPN 0. Definitely want this to be no shut. Static IP address, we can set it right here. 10.10.1.108/24. Tunnel configuration is on. And save. Now I got to do VPN 512. And everything looks good there. Add a VPN interface for Ethernet 0. No shut. Ethernet 0. IP address, in my case, 192.168.1.108/24. And save. What? Okay, I could have sworn I copied and pasted there. Save. Create. Attach. Be smart. There. Go. Wants me to set hostname. Be smart. System IP 777.108. Site ID 1. Update. Next. Okay. I knew there was going to be something that got me on this one. Something about this that got me. It's going to be vSmart. The vSmart. So the final step, activating the policy. Oh, yeah. Activate NAT on the Biz Internet interface. Forgot that too. That's going to be important. You can do that right now. Templates, features. This is going to be on the gig E00 interface, right? Interface gig E00. Edit. Now, this is finicky. You can't set this to global. You got to set it to device specific. Otherwise, for whatever reason, NAT just never happens. Check off the box over here on the right. Next. Configure. Send it. That was right. Gig E00. Yeah, internet. Okay. Just make sure it's all there. Want to see that success message before I try and push all these policies out. Okay, success is there. Back to policies. Activate the mega policy. Oh yeah, now that it's actually managed by vManage, you have to tell it to be managed by vManage. Controllers, vSmart. Device bring up running. Oh yeah, change mode right here. Change mode, vManage mode. Could have sworn I had attached this. Could have sworn I did that. Site ID is 1. Okay. Update. Next. Push it. Oh, failure. So here's the thing. At this point, I've rebooted the devices, all the control plane, brought everything back up. And this apparently is just a bug in vManage or a problem with the virtualization platform. But this pushing feature template configuration is completely stuck in pushing that configuration, that template to vSmart. So there's no way around it. You can't, there's nothing you can do to kill it. And there's nothing you could, outside of completely tearing down the lab and rebuilding it. And we're on the last step. And I know that everything I did works because I've done it a million times. So in this case, it's kind of unfortunate. You'll just have to trust me that we're going to have to take a leap of faith that once I had deployed that template to vSmart, I could have activated the policy and it would have worked fine. And if you need to double check me on any of those things, we can watch the SDWAN content on CBT Nuggets, because I recorded how these things all work and how to deploy them from scratch. So yeah, here on the very last two steps, I'm positive that the policy that we created, which I can go to policies here, and we can view the mega policy. I'm positive that these policies, the two policies, the topology policy, as well as the traffic data policy, would have done the trick had we been able to successfully push the template to vSmart and control vSmart from vManage and not just blow the whole thing up. But I've been waiting now for several minutes, and I've rebooted the devices, and it's just stuck right here. So anytime I try to push it again, it says like we're still waiting on the first operation to finish, and it's been rolling now for just over 20 minutes. So yeah, if it's safe to say this just got hosed up, and I'm sorry that we couldn't get this finished in just the cleanest way possible, but I do know that the configurations I deployed worked. So anyways, I'm sorry about that, but that is the SD-WAN tasks now all checked off the box. We brought the vEdges on board, used all the template configurations and assigned configurations to them, brought up an OSPF adjacency, and then created a centralized policy that stopped the advertisement from one loopback at one site to another site, as well as enabled direct internet access for the VPNs, which also did a little bit of route leaking too, leaking routes out of VPN 5 into VPN 0. So that's it. Thanks for stopping by, y'all. I'll see you in the next one.